Right now, as you watch this, your head is aging faster than your feet, not metaphorically, not philosophically, measurably. Physicists at JILA in Boulder have detected this difference across a single millimeter of height, 1 millimeter. And that's not even the strange part. The strange part is that we've already built machines that correct for this, and you used one today. Probably to get lunch. This is Timing Melt, and we're documenting an investigation into time, what it is, how it works, and whether it can be manipulated. And what we found this week stopped us cold. Because we went looking for the frontier of time manipulation, and we realized we'd already passed it. We passed it decades ago. Every GPS satellite orbiting Earth right now is a functioning time manipulation device. Not in some loose, poetic sense, in a precise engineering sense. GPS satellite clocks gain approximately 38 microseconds per day over ground clocks, 45 microseconds gained from weaker gravity at orbital altitude. -7 microseconds lost from their orbital speed. Without relativistic corrections, without actively accounting for the fact that time flows differently up there than it does down here, GPS would accumulate about 10 kilometers of positioning error per day. Your phone would think you're in the next town over. So every GPS receiver on Earth runs relativistic correction algorithms, every single one. We built time manipulation technology, mass-produced it, and put it in your pocket. We just don't call it that. Let's be precise about what we're claiming here, because this isn't speculation. This is among the most experimentally verified phenomena in all of physics. In 1971, physicists Joseph Hafele and Richard Keating bought seats on commercial airliners, strapped cesium atomic clocks into the adjacent seats, and flew around the world. Eastward flying clocks lost 59 nanoseconds, plus or minus 10. Westward flying clocks gained 273 nanoseconds, plus or minus 7. Einstein's equations predicted minus 40 and plus 275 respectively. The match was extraordinary. They proved general relativity with airplane tickets, but here's what makes this visceral: cosmic ray muons. These particles are born when cosmic rays slam into our upper atmosphere, about 60 kilometers up. A muon's lifetime is 2.2 microseconds. At that lifespan, even traveling near the speed of light, a muon should only make it about 660 meters before it decays. It should never reach the ground, and yet muons shower down on us constantly. They reach the surface in enormous numbers. Why? Because at 99.5% the speed of light, the universe literally slows their clocks. Their 2.2 microsecond lifetime stretches long enough for them to cross 60 kilometers of atmosphere. Nature is manipulating time on a massive scale, all around us, right now, and it has been since before we existed. Now here's where this gets personal. In 2010, NIST scientists demonstrated that a clock raised just 33 centimeters, about a foot off the ground, ticks measurably faster than an identical clock below it. Measurably. Not theoretically. By 2022, JILA pushed this to the millimeter scale using optical lattice clocks with precision better than 1 part in 10 to the 20th. That's a 1 followed by 20 zeros. At that precision, the curvature of spacetime, the warping of time by Earth's gravity, is detectable across a distance smaller than a grain of rice. What this means for you, over a human lifetime, your head ages approximately 90 billionths of a second more than your feet. That is tiny. But it is not zero. It is a real physical difference in the elapsed time experienced by different parts of your own body. You are not living in a single time flow. You never were. We also found the human stories, and they're remarkable. Scott Kelly spent 340 days aboard the International Space Station. When he returned to Earth, he was approximately 8.8 milliseconds younger than his twin brother Mark. Not his watch, him, every cell in his body, every chemical reaction. Every heartbeat, all of it ran 8.8 milliseconds less than his brother's. And this brings up a misconception we need to address directly. Time dilation doesn't just affect clocks. It affects all physical processes, biological aging, chemical reactions, radioactive decay. A muon doesn't have a slow clock, it genuinely exists longer. Scott Kelly didn't have a slow watch, his biology ran slower. Then there's Sergei Krikalev. He was a cosmonaut aboard the Mir space station when the Soviet Union collapsed beneath him. He literally came home to a country that no longer existed. But he also came home roughly 0.02 seconds younger than everyone who stayed on Earth, from 803 days in orbit. He was, for a time, the most time-dilated human being who ever lived. An accidental time traveler in more ways than one. So let's step back and understand what this actually means for our investigation. We came into this project asking whether time can be manipulated. The answer is, it already is. Continuously, everywhere. The question was never whether time manipulation is possible, it's whether we can scale it. Right now, the boundary isn't between real and not real. It's between measurable but tiny and dramatic but unreachable. An astronaut gains milliseconds over a year. To get meaningful time dilation, say, a factor of 22, where 1 year for you equals 22 years for everyone else, you'd need to travel at 99.9% the speed of light. The physics works, the energy requirements are currently astronomical. But here's what matters for where this investigation goes next. We don't need to build a starship to study time manipulation. We're already doing it. NIST is driving atomic clocks to mountaintops. JILA is measuring spacetime curvature at the millimeter scale. Planned experiments on the ISS will test relativity at 50 times the precision of GPS. The tools are getting sharper, the measurements are getting finer, and every improvement reveals the same thing: time is not universal, it's local, it's personal. And it is physically malleable. Here's your takeaway, and it's one we keep coming back to in this investigation. The next time you open a map on your phone, you're relying on Einstein being right about time manipulation. The next time a muon hits the ground beneath your feet, the universe is proving that time is flexible. We didn't need to discover time manipulation. We needed to recognize that we've been swimming in it. What we're now trying to understand, and what we'll dig into next, is what happens at the boundary. What happens when time dilation meets quantum mechanics. When clocks get so precise, they start to bump up against the uncertainty principle itself. There's a 2024 paper in Quantum Journal exploring exactly this: quantum time dilation in a gravitational field. We're going to pull that thread. Because if time dilation is the proof that time can be manipulated, then the quantum boundary might be where we learn the rules of how far that manipulation can go. This is Timing Melt. The investigation continues.